Okay. All right. So this is the Northeast Greenland Caves project. So this is a project that's been run by Gina Mosley. She's done 3 trips up to Greenland, and I was lucky enough to be part of her third trip. So just to orientate everyone on where Greenland is, it's this big island right here. So if you consider Australia as a continent, this is the biggest island in the world. It's got one of the biggest reserves of fresh water locked up in ice. If you were to actually see Greenland without its ice cover, it's actually kind of a donut with a big hole in the middle. And that's because the weight of the ice has actually pushed the plate underneath the ocean. So that would kind of rebound, same kind of thing that we saw with the UK. But anyway, if all the ice in Greenland were to melt, it would raise the ice caps, raise the sea level by about 17 feet. So it's really important what's going on in the climate in Greenland and managing that, maintaining that with climate change, what's going to happen there and what's the fate of ice in Greenland. This is a model for 2019. This is showing the rate of melting over Greenland, the Greenland ice sheet. And so this graph is the standard graph for melting of the Greenland ice sheet. So this is cumulative from 1981 to 2010. And you can see like the wiggle, this darker line here is the average. And this blue line is the melt in 2019. And this map over here maps out the ice sheet, and anywhere in red had more than 1 millimeter of accumulated water on the surface of the glacier on July 31st, 2019. So you shouldn't really have any water on top of the glacier, and you can see that there's really a significant amount. So it's really important to understand how the climate's been changing in Greenland. One of the ways that you can do that is you can actually core the ice. So these are, this is just a rig that's set up to core. You can see you can get some pretty big ice cores down through. And it allows you to look at the history of the climate. So as snow falls in the winter, it kind of traps air. And as it gets compressed, that air gets trapped in bubbles, and you can actually pull CO2 out and actually measure the level of CO2. You can also get an amount of precipitation. And in the summer, the snow melts, and so you get a layer of ice, of water that freezes as ice. So you can literally count back the years going from snow to ice, snow to ice, snow to ice. And that allows you to basically go in, not only look at levels of precipitation, but pull these air bubbles out and look at the levels of CO2 in the atmosphere over time. And you can do that in Greenland to about 140,000 years ago, because that's how deep the ice and snow is at the middle of the glacier. So if it gets, basically when the snow and the ice falls on the glacier, it kind of squishes it. And like, I think you can imagine toothpaste, it squishes it off the edges of the island. So it can only get to a certain thickness in the middle, and then it kind of migrates to the edges and casts off its icebergs. So you can go about 140,000 years ago. So you can go through the last ice age, but you can't get anything into when Greenland was wetter and warmer. So more like the conditions that we anticipate we're going to see with climate change. So to look into that, Gina is interested in the geology of Greenland. So this is a map. This band up here is 80 degrees north, so we're way up there. And this brown here is limestone. So of course, if you have limestone, you have the potential for caves to form. And in the 1960s, there were some US cavers that went there. The US Air Force was thinking about putting in military bases in northeast Greenland so that they could actually attack Russia with nuclear bombs from Greenland as a staging post. So they actually looked at this area to put in a number of different landing strips that would be big enough to hold these planes that could carry nuclear bombs. And so you have to have permafrost, you have to have permanently frozen ground so that it can support the weight. Anyway, these two cavers were up there. They were geologists. They were mapping a lot of the geology of this area. The area is called Centrum. It's based on this big lake we called Centrum. And they found a valley that had 16 described caves in it. And they published this in the NSS Bulletin in 1960. And it basically sat there and nobody did anything with it until somebody brought it to the attention of Gina Moseley. And then she wondered whether that might be a place you could go and look for speleothems. So you can do paleoclimate reconstructions with ice, and you can also do them with speleothems. So just like with ice, as water drips into a cave in the summer, you have more drips, you get more precipitation of like calcium carbonate onto a column or a stalactite, and that builds up over time. And you can actually look at the stable isotopes, the chemistry of that calcite, to determine what the conditions were. So it's possible to go a lot further back. So this is a map of Centrum. So this big lake down here is Centrum. So this spit of land sticking out here is actually where the US Air Force was thinking about putting in a airstrip. So this is all permafrost. And this area here at the top is where the caves were discovered. And this is a map of a trip that Gina did in 2015 to actually try to get to those caves to determine whether there was any calcium carbonate there. So they had a boat, they chartered a plane, they landed a boat, they took the boat across the lake. It turned out the lake was a lot shallower than it looks from the air, so there was a lot of dragging the boat across the lake. They get the boat to the far side of the lake, and then they had to hike 47 miles around a valley to get into where the caves were. So this is them hiking out. You will notice that everybody, in a lot of the photos here, you're going to see people with guns. Polar bears are endemic up there. And polar bears are different from other bears in that humans are food. They're not scavengers. They don't eat nuts and berries. If they see an animal wandering about, that animal is food, including humans. And there's been a lot of incidents with people being attacked and eaten by polar bears. So you're not allowed to go anywhere without a gun in Greenland to defend yourself. This is the valley they got into that had the described caves. So you can see there's holes all over this cliff face. So actually you can see somebody up there standing by that entrance there. This is, that's, what is that, U-shaped cave. Strangely enough, it goes in and comes out again. And then they got into some caves. This is Crystal Palace. This is looking out on the Grotsdalen Valley. Now this is a really unusual area because you notice there's no ice here. So this is actually a polar desert. You're actually a lot further north than where the majority of the snow falls in Greenland. And because of that, it doesn't get much snow. It only gets about 6 inches a year, maybe 5 to 6 inches a year of snow. So it's pretty dry. It's very barren. Less than 2% of the surface is actually covered by any kind of vegetation. It's nearly all cryptobiotic soil. So if you've ever been in the desert southwest and you've seen that soil that you're not allowed to step on, because if you step on it, you crunch 200 years worth of cyanobacteria growth. This whole area is just that. And I spent a lot of time trying to avoid stepping on that stuff before I realized that the landscape is cryptobiotic soil. And it gets pretty cold. It gets down to about minus 50 degrees centigrade in the winter. In the summer, when we were there, the warmest day actually got up to 16 degrees centigrade, but the average is around 2 to 3, so just above freezing most days. Anyway, this is Crystal Palace, and Gina was able to find the deposits that she was looking for. So these are the calcite deposits. You can see the banding in it, and she can use that banding to reconstruct the climate. And so from her expedition, she was able to collect samples that allowed a climate reconstruction from 400 to 550,000 years ago. So that's getting into some deep time for this area, and really important window into conditions that were warmer and wetter. So she was hoping that we could go back and maybe find a bigger window from 140 to that 550 year range to try to understand when these caves weren't frozen and it was warm and there was drip waters coming into the caves to make formations, what was going on in the climate. So to do that, Gina got a SMART award, which is a multi-million euro award from the Austrian Science Foundation to study climate change in northeast Greenland using the deposits found in these caves. And when you put an expedition together like this, you have to charter planes, and planes have so many seats. And it actually costs as much to get 4 people up there as it does to get up 10 people up there. So in addition to Gina and her graduate student Paul, Chris Blakely, who works for Petzl, so we got lots of Petzl toys, and Robbie Schoen, who's Gina's fiance and also a Nat Geo photographer. They brought along a bunch of scientists. Adam Ignacy is a glaciologist from the University of Sheffield in the UK. Andrew Saul is also a glaciologist from the University of Sheffield. Paul Smith is a geologist from the University of Oxford and did a lot of the mapping, original mapping in this area. I'm a geomicrobiologist that focuses on caves, and then Pete Hodgkinson was our medic. In order to have sufficient insurance to be able to actually have an expedition like this, they required that we had an on-site emergency room physician with us. And luckily there's lots of ER docs that love to go on crazy expeditions. So Pete came along as the medic. And you see there's 2 people here that I haven't named. And that's because we had our own helicopter. So it's such an extreme region that walking around, you can see they had to hike 47 miles one way to find the caves the first time. So what Gina decided to do was actually rent a helicopter. So we had our own helicopter for 3 weeks. And you can see she's actually put our logo, she put a sticker on the front of the helicopter. So this is our pilot, Stig Eriksson, and the mechanic, Hans Christian. We had the helicopter rented for 3 weeks, but that's only 6 hours a day. And we were 2.5 hours from the nearest fueling station for the helicopter. So the way we had it is we'd have the helicopter come up for 3 days, stay with us. They would actually sleep in the helicopter, and then they'd go away for 3 days. So we were actually able to get a full 12-hour day with the helicopter and then 6 hours on each side. So we did a lot of ridge walking by foot, but we also did an awful lot of ridge walking by helicopter. And after spending 3 weeks ridge walking by helicopter, I think I'd prefer that, strangely. Getting everything up there is really tricky. There's no commercial flights. There's only one boat that goes up every 2 years to fuel a weather station up there that's called Danmarkshaven. So Gina actually had to plan this expedition a couple of years in advance, and all this equipment got shipped up about 18 months before we arrived. So this is all the boxes of food. You'll see these again. So this is Gina packing everything up to go on a boat over to Greenland to refuel Danmarkshaven and get dumped off at the same time. I had to include all of the science gear, a lot of the equipment. We were only allowed to carry 20 pounds of our own gear with us because of the weights for the planes. So everything we thought we needed had to be shipped in advance. And we also had to ship all the fuel for the planes and the helicopters as well. So this is just the route that we took. So this is Greenland here. This is Iceland. This is Svardsborg. I have a hard time pronouncing that. We flew into Reykjavik, which is the main international airport in Iceland. Then we took a commercial flight over to Akureyri, which is the northernmost airport in Iceland. From Akureyri, we rented a plane. So we basically chartered a plane over to Constable Point. This is actually a commercial airport in Greenland where a lot of tourists go. This is the airplane that we chartered. It's a Twin Otter, and everybody got super excited when they saw this. I didn't know a lot about them, but apparently it can take off and land in 180 feet, and it can carry 1,000 kilos of cargo. So it's quite an impressive plane. It was a lot of fun to be in, actually, a bit cold. This is looking out. This is going from Akureyri to Constable Point. So this is going across the North Sea. You can see the sea ice. This was in July. We had to get there the warmest time of the year. The warmest month up there is July. This is Constable Point. So it's a commercial airport. It actually has a Hilton, which is this building right here. We actually said it was a -2-star Hilton because it was the most rustic building I've ever been in. The toilet was actually a big garbage bag, because there's nowhere to store anything. So you literally just poop in a bag, they bundle it up, and then it all gets flown out. But this used to be a US Air Force base, and it was sold to Denmark, that oversees Greenland as a protectorate. And so they use it as basically the jumping off point for tourism. So a lot of tourists that come in actually land in here and then go off and hiking tours from this area. It's pretty rustic. We've got the plane fueled up, looking out across the landscape from Constable Point. We flew from Constable Point to Danmarkshavn. So this is the northerlymost weather station in the world that's permanently manned. It has 5 people full-time staff. It was all men. Gina and I were told to be really careful about what we did when we were there, because they get stuck up there for 18 months at a time and they don't get to interact with women. So we had to be careful, but I made them tacos and they thought that was brilliant. Again, we had to, the same plane that we used, we refueled at Constable Point and then took to Danmarkshavn. Flying over more pack ice. This is on the way up to Danmarkshavn. Just scenery. And this is Danmarkshavn. And it's a pretty famous place for Denmark. It's where a lot of the exploration for Greenland and the North Pole took place. So if you imagine, if you think about, Antarctic exploration and McMurdo and everything that went on down there, this is like the Danish equivalent of it. You can see these shipping containers here. So these are the shipping containers that get dropped off once every 2 years that contain all the food and the fuel for the people that are living at Danmarkshavn. So one of those shipping containers was ours that Gina had sent out in advance. This is baggage claim at the airport. So our plane landed, and then the guys were kind enough to go over with a digger so we could throw all our bags in and wouldn't have to carry them. They had a little cabin that we could stay in up there. This is getting everything ready. So this is opening up our shipping container. You can see all those boxes of food. It's getting the stoves ready. In the back, you can see the canisters of fuel. So we had to bring all of our own fuel. Constable Point is the last place that you can actually fuel an airplane or a helicopter from. So everything had to be done by staging our own fuel. So this is, the plane dropped us off, and then it had to do a bunch of fueling runs up to Centrum. So you can see that the pilots here are actually filling the plane up, and at the same time, they're putting barrels of fuel in the back of the plane for the helicopter. And they did a couple of trips up to Centrum to actually drop off the fuel so that the helicopter, when the helicopter got there, it could fuel up and then could actually fly around and take us to places to see things. So there was a tremendous amount of logistics, not only getting everything out to Danmarkshavn plenty of time in advance, but also, being able to dump enough fuel that far north to be able to support a field operation of this scale. And we got to see polar bears. There were polar bears wandering around at Danmarkshavn. This is a mama bear. There's a couple of babies. She was teaching how to catch birds out of the air, which was pretty interesting. So this is Danmarkshavn. The plane fueled up, took us up to Centrum. So we're right at 80 degrees north. So this is flying up to Centrum. So going over the glaciers. This is the second biggest glacier in the world that we flew over the top of. So the biggest one is in Antarctica, and this is the biggest one in the Northern Hemisphere. So the glaciologists got super excited. You can see how it's all scratched the surface of the land there. So very typical glacier. It was big. It was 40 miles across. And this is Centrum. So this is the landing strip. We kind of flew in, we banked around, and this is permafrost. So this is permanently frozen. So we were able to land the plane there. So this is some of the fuel that they stashed already for the helicopter for us. This is the plane coming in with more fuel. And this is us pulling all of our gear off, as well as the fuel that was already stashed there for us. And then once we'd fueled up, we had to get to the first set of caves, which were up in here, where we set up our first camp, which was the Grossdalen camp #1. So to do that, we had the helicopter. So it was a boat ride and a 47-mile hike one way for the team in 2015, but it was a 10-minute helicopter ride for us. So the helicopter could take about 300 pounds every ride. So a couple of us and some gear could jump in. And the helicopter would take off, dump it. See, a helicopter pilot has his own gun there, because apparently polar bears like to go after helicopter pilots in their helicopters. And then this is our first base camp. So this is that cliff that had all the caves in it. This is our food tent. So it's typical bear, I wouldn't say bear behavior, because we're the ones that are trying to avoid getting eaten by bears. So this is basically downstream of where we were sleeping. So this is a food tent, and then each of us had our own box of food. And then this is our camp that was set up, so a couple of 100 feet away from where the food tent was. And something that was unusual, I'd never seen before, is this bear fence. And I don't know, I've been in grizzly country, but I've never seen anyone set one of these up. So you basically pound these stakes in about 3 feet off the ground, and then you tie these rape alarms with some cord to them. And then if something wanders into camp, it catches the cord and rips it out of the rape alarm. So I think hopefully this will work.
Grr, I'm a big hungry polar bear.
So if that happens, everybody had a loaded gun in their tent. So these were high-powered rifles with armor-piercing bullets, because I guess the fur of a polar bear is hollow, and because the fur is hollow, it acts like a bulletproof vest. So you need these armor-piercing, high velocity rifles to actually hurt a polar bear. So everybody's got one of these in their tent. They're sleeping. You get up to go for a pee, and you have to be really, really careful that you don't accidentally wander into that bear fence, because about 5 people are going to jump out armed. But the reason we put them up is because if a polar bear does wander into camp, it gives you about 2 or 3 seconds of notice that you can get ready. And it was actually 24 hours of sunlight when we were up there, so it was kind of interesting camping. So one of the things I did not know about Robbie Schoen, so a lot of people probably know about Robbie as a big cave photographer, is he's got a thing about building toilets, and we called them the Schoen thrones. So this is one of Robbie's Schoen thrones. So you can see there's a big pit, and he's got these little shelves, and he likes to find sandstone because it warms up in the sun, and so it's more comfortable. This huge boulder that's part of it used to be up here. He trundled this all the way down. He's got a little backrest and a footrest, and you do your business, and then you cover it with a little bit. But they all have pretty tremendous views. So this is the stream that we use. This is some glacial melt that we use for eating and drinking. So we're upstream about 300 feet from this, and then there's our medic on the Schoen throne enjoying the view. And we only saw like 2 wildlife the entire time we were there. We didn't see any polar bears or anything, but we saw a muskox walk by, and we saw a bird. That was it. That's all the wildlife we saw the entire time. And the weird thing about the bird was, you see birds and you don't think much about it, but when you haven't seen one for weeks and one just kind of lands in the middle of camp, everybody stops what they're doing to look at it. So this is the cliff that we were investigating the caves. So there's a bunch of caves around here on the south side, and then there's some here. I guess that would be the east side. So we spent a day going up from this side, or actually 2 days going up from this side, a day going up from this side, and after that the helicopter showed up again. So pretty steep, epic getting up there. Really, I became a double black diamond boot skier, gravel boot skier doing this stuff. It was really, really hard work going up and so much fun going back down. Lots of cliffs to traverse around, so we had lots of ropes. You can see pretty exposed to get into these caves. And this is looking down in the Grotsdalen Valley, and I'll never get to go to Mars, but I think this is probably as close to the view that you could imagine you would see if you ended up on Mars. This is a cave entrance. This is looking down at camp. So you can see where our tents were in a straight line, because you want to be careful if a bear does wander into camp that it's not trapped by a circle of tents. So there's all our tents. This is actually an experiment that somebody set up to capture insects. Our food tent is down around the corner. The shown throne is down around here, and here's our helicopter. And then this is inside the cave. Gina's got some rock samples here she's looking at with Paul, her graduate student. Here's Chris actually using, we had an angle grinder that could cut rock that was battery powered, so you could actually collect the samples we needed. And this is one of the things I really enjoyed. All these caves are in permafrost. So there's ice caves are quite common, and you can get ice caves when you have a cold trap and cold winter air gets trapped. But these caves are actually in the permafrost zone. So they're actually in the frozen ground. And so the rock of the caves is a lot colder than the air blowing around. So any moisture in the air, if it comes in contact with that rock, will actually freeze to the surface, and you get this hoarfrost. So it's kind of nice looking hoarfrost. Some of the hoarfrost crystals that we saw were about a foot in diameter. So it was really pretty remarkable stuff. I got to do the cartography. In addition to being a scientist, I was a cartographer. So this is me. I've got my, I'm doing my distos. It was really, really hard to calibrate the distos because the magnetic field lines are dipping into the ground at about 80 degrees or 82 or 3 degrees. So calibrating a disto just took forever. But anyway, I got to use a topo droid on a phone to map the caves, but the caves were so cold that the battery kept freezing on the phone. But we were able to map them. The average temperature of the cave, the ambient temperature inside was usually between about -10 degrees centigrade and -14 degrees centigrade, but it did actually get down to -17. And as far as we're aware, that's the coldest cave that's ever, ambient cave temperature that's being recorded. You can see that this is mapping the frost. We actually were able to do some pretty basic climate studies based on where these frost lines formed. This is from Crystal Palace Cave. This is a microbolite, so basically a biofilm, a bacterial biofilm that's been fossilized by calcium carbonate. So it suggests that maybe there was some kind of bacterial activity that formed these caves back when they were originally forming. So maybe some sulfuric acid, there's some sulfide in the rock down there. So we think maybe there's, and some bitumen, so maybe there's an organic carbon sulfur cycle going on that might have helped create these caves. This is climbing up into Cairn Cave. So we called it Cairn Cave because there was actually a cairn inside. So Chris is a pretty good climber and was able to rig it so the rest of us could get up, looking out into the valley. We called it Cairn Cave because it had this cairn, and we think this was built by the cavers that were there in the 60s. These caves are really typified by these ice plugs. I know that when we had the presentation on Castleguard, Katie was talking about the ice plugs there. So there's no glacier on top of this, so this isn't getting excluded from glacier, but there is wall-to-wall ice at the back of these caves, and you can actually see around the edges, and you can see the cave continuing. So we're not entirely sure what's happening here. Somehow ice is getting extruded from these caves, and nearly all the caves ended in these ice plugs. So we think that they go a lot further. We think maybe this is groundwater that is under pressure, and under pressure it stays liquid until it comes into contact with it loses the pressure when it comes out into the open cave, and then immediately freezes. But all these caves tended to end in these ice plugs, but you could see a long way. So I think these caves could probably be a lot bigger if all these ice plugs weren't there. This is something I notice. I think this is caused by cave climate. In the entrance zone, it gets a little bit warmer in the summer, and you get condensation. So the the rock is frozen, but as you get near the entrance, the surface temperature actually warms it up a little bit. So instead of the water freezing instantly to make hoarfrost, we think you get condensation that freezes on the surface of the rock. So it's a slightly different process, but it tends to make these little fingers we've never seen before. This is just a close-up of them. So they're about 7 millimeters long. They're too fine to be formed by dripping water, but you can see there's kind of a surface here that ends in them. That's why we think it's a condensate. So we think the condensate is freezing, and as the condensate freezes, the calcium carbonate precipitates out, and we actually have isotopic data that suggests that these are formed by the freezing of very pure water, like you would expect in the condensate forming on the surface. So we think that this is actually a new kind of speleothem that we've found. I actually would love to know if those are in Castleguard as well. So this is at camp. Here's one of our samples, having a look at all those nice bands. So that was camp 1. Then the helicopter showed up and we got to do some ridge walking by helicopter, and we found this valley here that hadn't been described before. So we took the helicopter and we went looking for caves. So this is the head of the valley. We started flying up and down. It was like Star Wars at the end where he's like trying to blow up the Death Star. I swear there were times when the helicopter pilot was hovering outside of a cave entrance so we could see if it was a cave. And I don't know how the blades of the helicopter were not hitting the rock. We were that close. This is one of the caves that we found. We call it Kate's Cove. Our helicopter pilot, Stig, actually noticed this when he was flying over to get us. He got super into trying to find caves. So he was the one who found this, and Kate was his wife. So we called it Kate's Cove. This is landing. It's really hard ridge walking with a helicopter. You have to land it and walk up to the entrance. This is the entrance. This ice here, we think is formed from melting of the hoarfrost. You can see the hoarfrost back in here, looking at the entrance. And then we found this really defined zone here. We think that this is due to cycling of the air. So hoarfrost above, moist air being pushed out of the cave, and with the moisture freezing on the rock. And then as it freezes, the cold air drops, loses its moisture and flows back into the cave. So you get kind of this cycle, and you get this nice slice through the ice. You see it in all the caves of any length had this kind of sublimation horizon. So this is the map of Kate's Cove. This is the back of it, and we got down to minus 17.1 degrees centigrade, and I'm not quite sure what that is in Fahrenheit, but I think 2020 is about where they average out. So a very cold cave. There's nothing in the literature as cold as minus 17.1 for ambient temperature inside a cave. So we then packed up. We did a bunch of work there. We packed up the helicopter and moved camp. We went to the south. There was a cave here described by some French researchers, so we went down there, checked that out. So now we're on the south side of the lake. Super weird, corroded landscape from all the wind and the ice. Really impressive limestone cliffs. And then we got to Côte de Quartier, which is the cave. So very different kind of geology here. You can see the dip is almost 90 degrees. And this we thought these might be caves as well, but they weren't. But anyway, you could go in this entrance here and pop out that entrance there. So this made it the deepest cave in Greenland. So you can see a couple of people up there. Really big entrance. It's quite nice inside. Kind of interesting, it curled around on top of itself, so there was actually some phreatic development. So we spent about a week checking this area out. We didn't really find any new caves, even using the helicopter. This is our last night there. Gina wanted to cook a traditional Austrian dish for dessert for us, and this is her Austrian graduate student who was seriously not impressed with what you could do with an MSR stove. Then we got the helicopter, packed up camp. We decided to actually put a camp right where we found Kate's Cove, because we ended up finding about 73 different caves in this canyon. So we wanted to put a camp right on top of it. So this is our new camp. See, it got to the point where like just taking the helicopter to go do things in the morning seemed pretty normal. So it was getting terribly spoiled. And this didn't have a great water source. There was a river below us that we could have gotten water from, but it would have been quite a hike. And we didn't want to be down by the river because we'd have been penned in a bit if there'd have been polar bears. We had plenty of escape routes up here. So we actually managed to find a little snowbank, and we actually built kind of a dam and a faucet so we could have running water at camp. And then Robbie built another shown throne. So this is our medic displaying it. And I have to say, I sat on it, and this is a picture I took while I was sitting. That you can see this is the route down to the river below us. But this is probably the most impressive toilet view I've ever had in my life. You can actually see the edge of the snow cap up there. And this is the canyon. You can see lots of cave features. It was actually pretty tricky to get in and out of it. There are a couple of scrambles that we could do to do that. Checking out caves, more caves. While we were there, we took the helicopter, did some ridge walking. We found an additional valley that hadn't been described before. And we, Stig and Paul and I actually found this one, which we called Stig Strikes Again, because Stig kept finding caves. This is a really big entrance. Again, pretty impressive hoarfrost. This is about minus 11 degrees centigrade in there. And this is, Katie, to see this, this is that ice plug I was telling you about that you could see in several meters. So you can kind of see the edge of the ice here. And if you see, this is a rock. So at some point, the ice picked this rock up here, and it stuck to it, and it just carried the rock with it. You can see there's a bit of sublimation. So it's all smeared up here because we discovered this room. I had to dig into it. It was full of debris, so I dug into it with Paul following me, and he wasn't a caver, and he had a bit of a moment when we got in here. So I had to squirm myself right up against the ice, and Robbie yelled at me because he didn't get this perfect ice picture when we got in there. But this is looking back into it, so you can see the rock of the cave behind it. So this thing's getting extruded like a huge bubble, and it's perfectly clear. So this is ice that's taken a very, very long, slow time to form, oozing out of the cave. Whether it makes cave or it just filled void, we don't know. But this is lots of dry debris down here, the calcite getting desiccated. This is just a map of that cave. Another big ice plug up here, and then the ice plug I found down there. So again, potential for this to be a pretty big cave. And then this is a picture I took of Paul from the entrance to one of the bigger caves that we found, which was Swirly Cave. So we actually had the helicopter just drop us off here. He just landed on that pad. I think we're waiting for him to come back. And when you turn around and look the other way, you can see a pretty good cave entrance. And this is Swirly Cave, which I didn't think was a great name, but they loved it. They thought it was great. And again, ice plugs and pretty big formations, ice formations. And then this was one of the last ones that we explored. So this is about 81 degrees north. So this is the northerly most explored cave in the world. And it's limestone. We actually kind of swung around, found these things, and landed in a helicopter there. This cave actually has another entrance on the far side, but there's a dig between. There's no physical connection. Again, that sublimation line to show there's a significant cave with this hoarfrost melted ice. These are where we found the really, really big crystals. So the crystals in here are about a foot long. Again, some phreatic development. As far as the science, Gina did manage to get the samples that she needed. I think she took 300 kilos of samples back. The date on those, the age range of those, goes back past 600,000 years. So she's looking at alternate dating to figure out the actual dates of those. But it looks like she's got a really comprehensive set of speleothems in that area. This is something I discovered. So you can see there's a pretty good contact here between two different kinds of limestone. So this is the limestone that contains bitumen. So it's got organic carbon in it that microbes can use. This is an area, this rock up here has some iron in it. And you can see these weird deposits, brown deposits. So these turned out to be some botryoidal iron oxide deposits, which we think are biologic in origin. So there's some kind of iron reduction oxidation cycle going on in the rock, possibly before the cave was exposed, but maybe after the fact. And then this was pretty interesting. These were these spires that all pointed towards the entrance in the twilight zone of the caves, and nearly every cave that we looked at had them. And I'd seen them before in Borneo. This is a site I looked at it in Borneo. Each of these is about 3 to 5 centimeters long, and they all point again towards the sunlight in the twilight zone. So twilight, given you could see your hand, but you wouldn't want to try and walk around that kind of darkness. And this is called photocharon, and it's really common in tropical caves, and it was thought it could only form in tropical caves. And here we've got it up in the Arctic. So I think it might be doing something to do with the film of water, again, with that condensation activity that's happening with the cold rock. And then we found this. This is a pellet. There's some birds will actually nest in these caves. Some of the birds' nests that Gina's found, they've actually aged about 12,000 years ago. This appears to be a bird pellet with some green stuff on it. We looked at it. You can see this is ice all around it. So this is actually embedded in ice. This is in the floor of a cave in a dark zone. Again, you would need a light to move around. It's minus 7 degrees centigrade. It's very desiccating, so there's no water there. It's all frozen if available. And we looked at the green stuff under the microscope, and this is a chlorophyte. So this is an algae. It was actually integrated with the rock itself. So in addition to being these bird pellets, it's integrated into the rock. So this is a photosynthetic algae in a dark zone of a cave under minus 7 degrees centigrade, which is not unheard of for this particular species, but they've only ever been described in Antarctica before, not in the Arctic, and certainly not under dark conditions like this. So something weird's going on there. It's worth looking into. So we did do a number of records. Mapped the world's most northerly cave. Now, these are not ice caves. These are carbonate caves. So they're not transient like ice caves. They're caves. Longest cave in Greenland, which was Kate's Cove. That was just over 330 feet long, to 100 meters. The deepest cave in Greenland, with this the Quarter, which was, oh God, it wasn't that deep. It was only about 64 meters deep. And then the world's coldest cave, minus 17.1 degrees centigrade. And then this is just flying back. Gina, with her huge box of rocks that we had to leave all our boots and coats and poles and everything behind, because the plane pilot wouldn't let us bring any more weight than the rocks. So Gina had to ship everything back to us at home so she could bring her rocks home. And then, of course, the thanks do go to Gina for actually putting on a pretty amazing expedition that was really, really hard to pull off, and I feel really fortunate to be part